Okay, so hello everyone. So this is day one of doing physics questions every day until I get a confirmed challenge. So today I'm going to do this question from this textbook as the end of chapter question from unit one. So let's see. I've never seen this question before. So let me see. So boat travels at 2 meters per second eastwards uh, towards a port 2.2 kilometers away. When a boat reaches the port, the passenger travel in car to car due north for 15 minutes at 60 kilometers per hour. So calculate your distance traveled. Okay, so let's draw a vector diagram first. Okay, so let's draw a vector diagram first. Let's use the color black. So boat travel 2 meters per second east. Okay, so let's say that our start point is right here, and then we go east. But this line is too thick. I'll change it later. You got 2 meters per second, 2.2 kilometers going this way. Okay, so this will be the port. So say A to B. Okay, so next we'll do when a boat reaches the port, the passenger travel in a car due north for 15 minutes. Okay, so right like that, like this. Okay, so let's be here. So from A to B, it is they go for 2 meters per second for about 2.2 kilometers away. Okay, and then from here, that is 15 minutes. They go for 15 minutes. Okay, and then for 60 kilometers per hour. Okay. Okay, so I'm seeing different units, so it's gonna be good. It's gonna be tedious. So I'm calculate the total distance traveled by the passengers. Okay, so let me think here. So distance is already given, and this distance is already here. So we can find the distance here. Okay, so let's find the distance. So number A, distance. So we use the normal speed equal distance over time formula. Okay, so T equals to ST. So I just substituted right away. As is 60 kilometers. Okay, I'll do turn 15 minutes into an hour, so minute into hour. Okay, let's do 60 kilometers multiplied by 15. Okay, 15 hours. I can divide that by 60 to get in kilometer. So let me use my calculator to solve this. And you get 15 kilometers. Okay, 15 kilometers. So sorry for my bad handwriting. I'm writing with my finger. It's not good. So the total distance. So total distance will be 2.2 plus 15, and that will get us 17.2 kilometers. So this is 17.2 kilometers. Okay, so number A is already done. Okay, number A is already done. So how to find the total displacement? Okay, wait a second. Let me change this. Oh no. Do this. Okay, pardon me. Okay. Okay, so total distance charge. Total distance travel. Okay, so now displacement. So there are differences between displacement and distance. Displacement is A to C. So I'll use a different color actually. Is it purple? So A to C is the displacement. So I'm gonna find the displacement. We can use the Pythagoras theorem like this. So we can use the Pythagoras theorem. So AC, or displacement, equals to square root of 2.2 square plus 15 square. Okay, so now I'll just use a calculator. I'm not doing this. So 15 and we'll get 15.16 kilometer. So displacement is 15.16 kilometer. Okay, now the total time taken for the whole journey. Okay, so let's see here. We already have the time here. It's 15 minutes. We don't have the time here, so we find the time here. Okay, so what is the time? So I'll write it right here. Never see the time. So we just use it normal. Let's see, go distance over time. So for time, distance over speed. So distance is 2.2. Speed is okay. This is gonna be a problem. So I like to turn, like in this situation, I like to turn the kilometer into meter instead. So I'm gonna do that. So kilometer into meter, 2.2 times 1,000. Meter, okay, and then the speed, which is 2 meters per second. Okay, and turn public shift. Okay, so now I'll just use the calculator. What is that? Yes, I use the calculator a lot. So 2,200 and then we do something like that, which will get this much seconds. So now I need to turn this second into hours and minutes. So 1100 and then divided by 60, which is 18.3 minutes. Oh, that was okay. So over 18 point minutes, 18.3 minutes. I'm sorry. 13.3 minutes. So now I just need to add the time together. So now total times, write it right here. Total time will be 15 plus 18.3, which is 33.3 minutes. Okay, so we're looking great right now. Okay, so now to find, let me write 33.3 minutes. Okay, so now I'm to find the average speed. Okay, so well, what is average speed here? So we have distance. So we have speed here. So we have this speed. Let me change the color. We have this. We have 2 meters per second. There's 60 kilometers per hour. Okay, we kind of know every the detail for this question. So now what's the average speed? So there are differences between average velocity and average speed, right? So average speed is the total distance combined. So we have this right here. So average speed in this case is gonna be total with AVRG. So average speed is gonna be total distance over total time. So what I'm going to do is I have to use the distance that I found right here, and then to use the time right here to calculate the speed. So it'll be 17.2 kilometer and 33.3. So I just need to divide that with my trusty calculator. And that will be 17.2 or 3. It's 17.2 and 33.3, like that. Oh, okay, it's got okay, 0.52. My handwriting is so good. Wait, what happened? Okay, 0.52 kilometer per minute. Okay, so let me turn that into kilometer per hour. Actually, I think that would be more convenient. So turn 30.2 minutes into hour. So this, okay, do that. We'll get 30.9, so we'll get 31 kilometer per hour. Okay, nice. We're doing great. Okay, we're doing great. Okay, so now, wait a second. Let me check. Okay, yeah, that's right. Okay, so anyway, so this will be the average speed. Average speed will be 31 kilometer. It's approximately 31 kilometer per hour. I'm sorry. Kilometer per hour. Okay. Now the last question. What is the magnitude of that? We're gonna say so. Magnitude of the average velocity. Okay, average velocity. Let me see here. So velocity in this case is gonna be displacement over time. So we have to use displacement. Okay, yellow might not be a good choice. Let's use let's just use black. Let's just use black. Okay. So in this case, number E right here, magnitude of the velocity. So velocity is displacement over time. Okay, I'm not gonna write that. So we found displacement, right? We found displacement, and then we have the time. Time is 30 minutes. So now, if you want to find velocity, I just need to do is displacement is 15 kilometer, 15.16 kilometer, and then this will be 33.3 divided by 60 hour. Then this will get a total of, let me use my calculator again, 33.3 over 60, 27.3 kilometer per hour. So this will be the average velocity of the whole journey of the passenger. Okay. So let me see if the answer is correct. 37.3. Okay, guys. So here are the answers to this question, and I'm gonna check. Okay, so for number A, 70.2 kilometer. Okay. Yeah, I forgot about this. Yes, it's a mistake by me. I'm sorry. We're supposed to add direction if we go displacement because it's a vector quantity, right? Yeah, I forgot about that. I'm so sorry. But we got the magnitude, right? So it's okay. 2000 seconds. 2000 seconds is basically 32.2 minutes, so I'm correct. 8.6 meter per second is about 31 kilometer, right? So yeah, it's approximately 31 kilometer, and 6.7 by 6 is 37.3 meter per second, or we're not kilometer per hour. Okay, so yeah, guys, thank you for watching this, and I'll see you tomorrow. And yes, I'll do this until I get a girlfriend. So yes, goodbye.